Hello. I think that I am live now. I'm gonna go post a link to this in Reswitched and then wait for people to show up. Okay, that's done, and now is the part where we wait for a couple of minutes. Man, it has been a while since I streamed. Hello, John Jaded. Yeah, no, it has been a rather a long time since I did any streaming. Hey, Turtle. Hey, this should hopefully be, moderately interesting today. I'm finally having finished. Hello, other people. Having finished Mesosphere, the next thing on my to-do list is getting Atmosphere working on Mariko units. And one of the things that does not work on Mariko is reboot to payload, because that uses a warm boot ROM exploit, and the Mariko boot ROM is not vulnerable to it. But that's thank you. But that's kind of a problem that we can't reboot to payload because Atmosphere uses that for a bunch of stuff, including fatal errors. And hello, people. And I want to be able to get fatal errors on Mariko because otherwise my life will be miserable. If people run into issues on Mariko and I just can't get debugging output, that would be awful. So I thought about what I could do about it, and I came up with this super stupid solution. And y'all. And my super stupid solution to the you can't reboot to payload problem is to observe that Mariko has an extra 192K of trust zone RAM. And that's a lot. Arista only has 64K of trust zone RAM. And that is enough space that I can shove another program in there. And so my plan is to shove a SDMMC driver and a display driver into the extra trust zone RAM on Mariko. And then when a fatal error happens, instead of rebooting, it will just jump to this Mariko exclusive program that will initialize the SD card and save the fatal error directly, and then display the information all without rebooting. And Laramie, this command window is serial output from my Mariko console. I yesterday spent some time finally getting debugging output from the secure monitor. I now have printf from the secure monitor, which is incredible. It's what a luxury. We live in 2020 now. And I'm not sure that there is a real upstream reason that Mariko has more trust on RAM other than, NVIDIA was upgrading stuff and they just added more trust zone RAM. I'm really not sure that there's a good reason for that. But yeah, so what I'm going to be working on today is this fatal error payload, which I've done absolutely nothing for. But that's okay. That is what streaming dev is for, and development in general. So yeah, I hope that it is at least mildly interesting to watch me work on. And I'm happy to answer questions about stuff that I'm working on with Mariko in general, or whatever, if people are interested. But yeah, I will give it another minute or so for people to filter in, and then I will get started. Are there any other questions about what I'm working on? And Sinestro, the state of Atmosphere in general, while we wait. Hey, Mythos. and yeah, here I have my Mariko's SD card mounted via USB storage, and it's totally normal. I'm using Hecate to boot right now because Fuse doesn't support Mariko yet. But yeah, this is all just normal atmosphere stuff. Right now, my console is like rigged to just read bootloader.bin off of the SD card and launch it. And this is just a like private build of Hecate that supports booting on Mariko. And yes, actually, I have ordered some Apple Silicon. I ordered one of the MacBook Airs, one of the new ones, or pre-ordered, or whatever it is. And I'm looking forward to running Mesosphere on Apple Silicon. What a meme that's going to be. I'm really looking forward to it. And yeah, I mean, glad you and the Atmosphere team have it working. I mean, the Atmosphere team these days is basically Hex KYZ and I. Hex KYZ is working on Fuse. That is totally his domain. And I am everything else. Which, you know, good and bad. Good and bad. But okay, let's get started. I haven't. Oh, did Bin2S get updated? MBL? I wasn't aware that you guys had actually pushed the update for it. I will have to, you know, update my makefile, etc. Including inevitable. Ah, yes, this is true. I vape. Okay, let's just demonstrate that this works. Let me build the actual Exosphere program. If I cd and then I make debug and copy exosphere.bin to exosphere.bin. My Hecate config is pretty simple right now. This is the one that I'll be using. It's just booting Atmosphere with the overridden secure monitor binary. So if I eject this, and then, okay, I ejected it, which means Hecate is like trying to spew stuff to the controller that I'm using for UART, which is why I get this garbage. If I hit launch and I hit Atmosphere dev, to give it a second, it should like print out the secure monitor boot process. Yeah, cool. And my my console is booting now, and it like just entered normal HOS. Okay. So yeah, we have printf, which means I should actually be able to do real debugging and development on stream and not have it be awful. And hopefully that's, you know, mitigates some of the fact that you can't actually see my screen. Cool. And yeah, make J16 is a lot of jobs, I guess. Let me see if I like Control Delete here, and then I do this. I do this. Yeah, so I am on a 3970X, and this is a VM to which I allocate 16 of the like 64 threads for the processor, which is like a nice compromise. But yeah, so this like garbage output that I'm getting, I think audio is just always really low. I can increase my mic again a little, but I suspect that has more to do with the fact that I'm just sitting a little away from my microphone. One moment, I'll increase it. Okay, that might be a little louder now. Anyway, so the garbage output is coming from the fact that I am using UART over a Joy-Con. My Joy-Con has a custom firmware installed to it that logs stuff over Bluetooth. And Hecate is trying to use the Joy-Con as a controller, and it trying to interact with the like UART logger as a controller causes all of the controller inputs to be printed to output, which is just all this garbage. And I don't know that I would call myself a gamer. I'm not super into games. I like roguelikes. I've probably put like 80 or 90 hours into Spelunky 2 since it released at the end of September. And I have like over 1,000 hours in The Binding of Isaac. And I guess I play Fire Emblem, Pokemon, and Animal Crossing. But that's about it. Yeah, okay, let's get started. So right now the big issue in testing is that we aren't actually doing a fatal error. Which I know sounds really stupid, but I hadn't set that up yet. So we're going to want to just edit Mesosphere, I guess, to, you know, reboot immediately to a fatal error. So let's see. Let's go to Mesosphere, source. Or actually, we can do better than that. We can do an actual fatal error instead of just using the kernel. Where if I go here and I go to Stratosphere and I go to boot, go here, and okay, the reboot payload will be set after here, which means that the kernel will know how to do fatal errors. So let's just do ams abort unless spl get svp pipe is not equal. There we go. Okay, that should work, I think. Then let me build Stratosphere, and that might take a second. But that should cause a fatal error to occur, like, first thing in boot, which is exactly what I want. Although, actually, I think that I will move this until after the screen has displayed, so that I can at least see that boot is working. So let's do it right here, after the splash screen is displayed and the battery charge is checked. And Stratosphere takes a couple of minutes to compile, so we have some time that we can do things while that's happening in. And the other thing that I'm going to need to do is, I think, and let me check this, that if I check my boot stuff, it'll be in boot power management, power utils. Where does the exception stuff actually happen? Do I need to update 11x? I guess I do. Atmosphere. I haven't updated LibNX in here for forever. Atmosphere, ox, LibNX, git status, git pull, stream master, make J16 install. I guess that's happening now. And yeah, compile time is basically CPU bound because of precompiled headers. Yeah, it's been a while since I was using this VM. Let's see, where do I have my exception handler rigged up? Crash handler, is that in here? It's gotta be. Crash handler. No, right, that's in the Stratosphere. It's Stratosphere. Where is the Stratosphere source? I think that's an AMS Exosphere API, probably. No. Environment, probably. Crash handler, great, okay. It's going to do stuff, and then exception handler is going to be here. And, okay, that's going to do a AMS PPC reboot, a fatal error, great. And if I check AMS down the middle, God, there's so much indirection here. I swear, I don't know why I have so much indirection in like everything that I do. Reboot to fatal error is dereboot to payload, which is force reboot to IRAM payload. Great. Okay. So let's actually change this, I think, because we don't really want to reboot to an IRAM payload. We want to reboot to fatal error. So let's make a new function. Let's call this force reboot to fatal error. And that way we can like act differently on it, which will be nice. Sphere and libraries. Okay, that's done. Stratosphere, include Stratosphere, AMS, API. Void force reboot to fatal error. Great. And then go back to where we were. API. Void force reboot to fatal error. And then we will make this a reboot type 3 for fatal error. How do you remember all this? I have a really, really good memory. I have just never had my memory fail me when I've needed it to. Also, yeah, I vape, and that is supremely helpful for memory. Okay. So that's that, and then let's go back to Stratosphere, J16. Okay. And while that's going on, let's go to Atmosphere, Exosphere. It's going to be Program Source, SMC, SMC Power Management. Although it actually might be User Power Management. I think it's this though. Reboot. Set config. Now, what did I actually do here? I guess that'll be in set config then. So, SMC info for config, set config. Yeah, Exosphere needs reboot. Okay, yeah, that's that. We'll go to User Power Management over here. Let's add user reboot type to fatal error is 3. User reboot to fatal error. Great. And then we'll go here. Way to perform user reboot to. So the enum is inside Exosphere. And the other file is inside Stratosphere, and like I probably should copy over the enum, but I'm lazy, and this is newer code that was written like a year after the other thing. Okay. And yeah, thank you. Okay, I think that's right. And then this is going to be simple. If SPL, or I'm not an SPL, fuse get SOC type, fuse SOC type, Arista, Arista, we reboot to fatal error, we're jumping, fuse a primaries, so in this case, we'll just return perform user reboot the payload. Else. Go. And in this case, jump Exosphere fatal program. And actually, there's other stuff that we want to do before then. Okay, things we need to do. Send SGI FIQ to the other CPUs. Other than 3. And I have something like this in the loader stub, so let me quickly copy paste that. I like doing return in void functions because it binds my API. This statement is only valid if perform user reboot to payload is also void. And so it's just a consistency thing that I like. Yeah, okay. And this, what did I call the memory region that is this? Libraries, lib, Exosphere, include secmon, memory layout, okay. Bridge module to zero Mariko program. Okay. Cool. Not there. Wrong file. Okay. I think that this should be good. I think. Probably. So let's then copy over the updated stratosphere that we need. And we need to build amos.met in the middle because that contains the crash handler that actually does the reboot to payload. And then we are also going to need to copy over the boot system module, since that's the thing that we are making do a fatal. If you considered accepting tab completion in CMD into your life, you know, I have thought about doing tab completion stuff, but I'm on Windows. Tab completion is kind of shit on Windows in my experience. It doesn't make a big difference to me to just type stuff out. And thank you, Turtle, for the comment about my code style. For obvious reasons, I am also very fond of my code style. And my code style is actually basically identical to Nintendo's, which is nice. It is very much based on Nintendo's. Although I don't think they do the thing with comments that I do. And they like use m underscore for member variables. But yeah, that's irrelevant. How can you tell? Nintendo's debug and development programs have assert statements, and asserts contain the full text of the expression that caused the assert. And so you can get like the names of variables and translation units and function names and actual statements, etc., etc., etc. I have no idea how Nintendo does commenting. I'm sure they don't, because my commenting style is kind of idiosyncrasy, and I have no idea how they do comments. But I know that in terms of actual code and expressions, my stuff is very similar to them. Boot 16. Boot. We should be good once this happens. And let's add a log here. Log. Jumping to Mariko fatal. I just prefer always using the single line comments like that. I don't like //. It seems highly unaesthetic to me. I mean, I don't have like a real reason for it. It's just when you like compare. I feel like this one is just objectively more aesthetic than this one. Yeah, okay, we have now built the stratosphere stuff. So let's, I don't think I need this window anymore. Let's go back to where we were. Let's build exosphere in. Yeah, I don't really care about ANSI C. I use C++20. Okay, that's that. And then I'm also going to copy over the fatal error payload. Debug. Yeah, so I use the word objectively there in a way that does not actually mean objectively. I know that this is a bad use of language in the same way that literally is losing its meaning. It's a verbal tick that I have to use the word objectively in the same not actually objective way that people use literally to mean not actually literally. I apologize if that irritates you, but it's a really ingrained verbal habit. copy Mariko fatal debug bin e Mariko fatal bin. Okay, and then I'm gonna need to edit my boot config too, I think. Theoretically, this should work. I haven't actually tested it, but CT did say that he was going to make this work. So I should just do exo fatal is Mariko fatal.bin. Okay, and then let's do a quick test here. It should be the case that if I go to the main, Mariko fatal source main. Let's make sure that we can actually tell that stuff is happening. I'm going to need to initialize the library from the same way that I do in normal Xsphere. So look at that to boot main. Yeah, I don't really know which libraries I'm going to use. We'll just do all of them. Yeah, that's probably fine. And then let us ensure that the log library is initialized. Log initialize, and then ms on log. It'll start. Oh yeah, I hate using namespace. I am super a fan of being verbose and clear and explicit about what we're using. Okay, let's build and copy that again. Okay, I think that should be good. And I guess now we test it. I have no idea, I just broke everything. But with any luck, we should see this jump to my code. Okay, let's boot. I should see the splash screen, which you can't see, and then it should say that it's going to the fatal payload. Okay, nothing. It's a little unfortunate. Okay, I wonder where it's going wrong. I'm not super surprised because this is very much my luck. It's also at AMS secmon log. Perform user reboot to fatal error. Oh, actually, I know exactly what this will be. Yeah, I'm just an idiot. To fatal error. It is important, I think, to actually jump to the code that you want to jump to. Yeah, not calling the function is, I think, pretty likely to be a problem. Okay, console's back up. Let me get USBMS back up. Cool. I think that should work better now. Okay, let's give that a second try. Okay, still a no-go, which is also unfortunate. I wonder why this is failing. Okay, so this user reboot to fatal is not happening at all. Oh. Yes, classic me, preemptively making my life worse. the above was only on Arista. And yeah, Ohio is something that the like real official secure monitor logs when it turns on and goes to sleep. And so I have that in as a little tribute. If I like open up the IDA database for the secure monitor, which I guess will be here, restore packed base, and then I go to log, you can see that in setup it logs Ohio, and then when going to sleep it logs Oyasumi. It's very cute, I have to say. Okay, this is take number 3. Take number 3 at calling a function. How many tries will it take for me to call a function? Hopefully less than 5. I'd be very happy if this, gets a little further this time. Okay, come on. Damn, still no go. Okay, so it's going to take more than 3 tries to call a function. We are doing a really great job here. Man, fuck, is this just not being called at all? Yeah, we can do better than that. Let's see what is happening. Yeah, no, I mean, the good news is I can log stuff, so that's super positive. Secondfig should be called by my crash handler inside Atmosphere, man in the middle. And that should be up and alive very early. So let's go to the SMC handler and just log all SMCs and see where we're failing. Okay. The splash screen is showing on my screen, and the splash screen can't show unless it has successfully contacted the BPC server and set the reboot payload. So let's fuck. Do I have reboot payload logic that makes it not work on Mariko in Stratosphere? I bet I do. I am that kind of stupid. Stratosphere source AMS environment in before. Anyway, this will actually be an AMS in the middle because this would be client logic source BPC MS service reboot for fatal error. And I bet that I do like the stupid Mariko thing here where I try to be intelligent. No, okay, it looks like I don't. Do reboot to payload, do reboot to payload. Interesting. Oh, G reboot type wouldn't have been set yet, but that shouldn't matter because we're doing a fatal reboot this way. Man, that's really weird. Okay, so never mind. This actually looks like it's fine. So let's log SMCs. MS on log bylaws. D X. I don't want to log the actual SMC arguments. Yeah, that's fine. This will like maybe contain key data, which I probably shouldn't log, but it's fine. It's fine. Hopefully, no important keys get logged. args.r1. Okay. Yeah, no, I was thinking this time, like mornings on a weekend, it works well for me because it's like right when I get up and when I'm working on stuff, and it's not horrible for people in Europe. Like early morning Pacific time is like afternoon, which works for the Eastern Coast in the US, and it works for Europe. So I think it's just a good time to do things. Okay, then let's check this and try it. Okay. Launch. Must have. Okay, this is try 4. Okay. It's doing a lot of system calls. Sure. It is infinite looping calling an atmosphere SMC, which surprises me. That's a lot of SMCs. Is it really? What is this? Man, it's so weird. Okay. So that confuses me. Since I don't think that's right. So let me turn off my view. And where did it transition here? Did it ever call set config? It's just interleaved output because it's logging a lot, and it's like UART over Bluetooth, which has some delay. Okay, so this is all like read-write register from the WEC driver. F201 is what SMC is that? Is that like atmosphere git config? Atmosphere program SMC handler. I already have it open. F201 is IRAM copy. It looks like it is forever copying IRAM data and like not advancing here. So that seems fucked up. Yeah. Okay. Console's rebooted. Link connection over USB. So why is it like forever doing the IRAM copy? That shouldn't be like fucked up in this way. Let me also log the other arguments so I know where it's trying to copy to. Because I guess it could be doing that. It shouldn't do that more than 64 times though. Fatal main. Starts. Also log. Marks.r2. Okay. Hello. I am working on. I'm adding like a fatal error helper for Mariko. Yeah, no, I mean, I figured that today would be a lot of, debugging stupid shit. But I enjoy this kind of work usually, and I hope that this is not completely unentertaining. Close launch. Okay, let's give this another try here. Cool. Interesting. Okay, no, it actually is trying to do a reboot. Interesting. Yeah, every 64 it is trying to do a reboot, and then it's just looping that and doing that forever. So what is happening there? Nintendo Switch development. Yes, Ray ate mushrooms. I am working on my custom firmware for the Nintendo Switch. So this is objectively Nintendo Switch development, I feel. I am the developer and maintainer of the custom firmware for the Nintendo Switch, and that is what this is a stream of me working on. Okay, so it is calling setconfig for this. Alright, the setconfig value is actually like args R3, so let's double check that one more time. Args.R3, args.R4. Okay, the good news is we are calling the fatal layer SMC, so we're receiving it, so we should be able to do shit. It is just going to be a question of why is this not calling the function I want. Yeah, no, my mic is a little quiet. It's a long time issue. Don't worry about it. Just turn your volume up. I'm sorry that it's low, but I can't fix it. Yeah. Okay. Let's check this again. And I mean, I can turn my mic up a little again. Here, let me try this. Okay, actually, let's do it even more. Is that better? Am I louder now? It's even more. Okay, I just turned up my volume substantially in OBS, I think. Maybe that helped. Fuck you, okay. I don't know why I bothered. Okay, let's go back to this. Launch. Okay. Yeah, it's logging shit. Nice. Showing the splash screen. WEC driver is doing it. Okay, there we are. This is what I wanted. Let me turn off my console so that it stops spamming me. Get it back into that gate. Okay. So here it is. And okay, that would explain it. It is still calling the reboot with type 2. And we want it to be type 3. So why is that happening? Let us go back to the stratosphere and figure out why. Hey, Nedley. Yeah, I mean, I can stream on weekends at this time. I just can't do this during the week because I have work at this time during the week. Let's go back to where we were in Stratosphere because that's where I fucked up, I guess. Mission libraries in Stratosphere, source, same as environment. Oh, you know what this is going to be? This is going to be in Stratosphere and AMS in the middle again. Source, PPC in the middle. PPC power utils. No, that actually is doing force reboot to fatal error. So that should be right, I expect. Ever considered quitting and becoming a full-time streamer? No, I love my job and don't want to do development instead of it. And also, I don't take enough baths to be a professional streamer, I think. Okay, so that should be right. Libraries, lib stratosphere, source, this exosphere API. What should be to fatal error? That should be doing type 3. I wonder if boot is like hard coding this logic instead. What should be the payload? Fuck it. Let's just see where everything that does this is. Find dot dash name b sargs grep. Okay, what does this? So boot does do it. It does do it for its own like reboot stuff. Stratosphere, boot, source, boot, power utils. I wouldn't have thought so. Do you reboot the payload? Yeah, no, we shouldn't be doing a reboot system. We should be doing it. Oh. God damn it. Fuck. Really? Ah. What actually calls reboot for fatal error? Boot main. Yeah, okay, god damn it. Yeah, I forgot that I overrode this. Yeah. I like just totally forgot that I overrode this. Yeah, okay. That's fine. Do reboot the payload. And do boot to get in there. Oh yeah, find xarg grep is the like best way to do that kind of thing. I love it. Do boot the payload. Then that won't take an argument, and this will. Speed do reboot the fatal error. Okay. And so now this should actually work. I forgot that boot was doing this because I'm just an idiot. Okay. CD stratosphere / boot make J16 and copy boot.kip e atmosphere kips boot.kip. You know, find xargs grep is how I always search for things. It is just my favorite way to do things. Hey, I'm glad that you like Hack Tool. Yeah, no, I've made a lot of tooling for the Nintendo Switch. It is, you know, one of my... The Switch is, like, my great love of the last 3 or 4 years. I'm happy that you like my tools. Okay. Take something. I don't know how many times we've tried to do this, but I'm guessing it's been a lot. And we're gonna do this one more time, and if this works, we'll remove all of the, like, SMC logging. But the fact that I can get printf from the secure monitor now is amazing to me. This is, like, such a luxury and such a dream come true. Until yesterday, I never had printf from the secure monitor. So this is just incredible from a convenience point of view for me. I'm so happy about it. No, this is still a Joy-Con debug. Damn it. Fuck. Okay, what did I do wrong here? This is still the same. Damn. Damn. Oh, okay. I'm just... Fuck, why am I so stupid? Okay. I swear. Okay, let's do this again. All of my problems are just me copy-pasting things and, like, failing to edit them appropriately. I, like, very rarely make actual logic error bugs. They're just all... Oh, yeah, I copy-pasted something and I didn't edit my copy-pasted lines correctly. And Laramie, the Joy-Con debug stuff is not mine. It was made by Deer, and... It is up to him to control releasing it. I'm not in charge of that, and I will not release things that are not mine to release. That would be beyond rude. No, as embarrassing as it is to say, I take a lot more care with contracts than I do with code. Because it actually matters if I get those wrong. Okay, take something again. Let's try this. Okay, come on, big money, no whammies. Big money, no whammies. Excellent. Okay, great. It looks like we did it. And the fatal code for Mariko is running. Excellent. Okay. So now we can actually do the things that we want to do. Great. Save this. And that is, yeah, no, that's really good. I'm very happy about that. Also remove this. And I wonder why it logged the extra space. Oh, I bet that there's a space after my perform user reboot the fatal error there. Was there? Probably. Oh, well, doesn't really matter. Okay. So, logging this. Oh, I bet that like initializing UART sends something. Okay. Yeah, I'm reinitializing UART, which is probably doing it actually. But why did it not log? Oh, obviously. MS log flush. Yeah, okay, it wasn't done logging this when I reinitialized the UART. And so it was like in the middle of printing that space when I reinitialized it. And so this flush will make sure that we are all good. Cool, that should be that problem solved. The quote-unquote problem, it doesn't actually matter. There is an auto flush on new line, but I mean, this started logging this, and then the fatal code does a reinitialize of the UART library, which like kills the UART and cuts clock and asserts reset, and so only one character was logged before, yeah. all this SD hot swapping. I am not doing SD hot swapping. Rage quit Snoop Dogg. I'm using USB UMS. No, the flush will help. The flush will fix it. Actually, no. I don't think I have flush on new line. Let me check that. Exosphere libraries. The Exosphere source log API. All right. No, wait. It'll actually be UART API. Yeah. No. Or I do. When I get an N, I send an R. Oh no, this isn't actually a flush. This is just waiting for me to be able to send characters. So yeah. There's no flush that happens on new line. Maybe I should add a flush on new line, but I don't think I need to. Yeah, I'll leave it this way for now. But okay. Let me get back into... Okay, mount the SD, copy stuff over again. We'll verify that it, still works, and then we will get started in doing the things that we actually want to do. Okay. Turning on the console. Console's on, tools, USB tools, SD card. And now it should work. And then we shouldn't need, I'm not going to bother making any more edits to like main Exosphere, I think, because it's now getting to my code. So we'll instead just go to Mariko Fatal. Yeah, I'm sure it'll be somewhere in here. There it is. Great. And then I'll turn on again. Your question, Ray Mushrooms, is just way too generic for me to answer. It's different for every game, basically. Its data is likely to be in the ROM file system. Okay, great. We are getting to the fatal payload, and we can start doing stuff. So, I had a test program for SD card stuff previously, which I called SDMC test because it didn't matter for me to be very original. So, let us get started. Let's make a new little SDMC, and let's also make a header. This will have a once, and SD card initialize, I think, should be fine here. I don't think these operations can fail. But let's do result initialize SD card. Oh yeah, you're right about that. Thank you, ML. And then this will have result initialize SD card. Also have namespace for a couple variables here. Let's do the same thing here. Port is the SD card port. The work buffer is work buffer. And normally these pins get configured by the boot sys module after initial pinmux config. I don't think that I need to do this pin config because this should already have done. This should have already been done by the bootloader. I should probably do this in like a more complete version of the payload, but I will add it later if it's needed. I don't think it's needed, and I don't know that I actually have the pinmux stuff mapped for the secure monitor right now, which I can change, but I don't want to do it unless I have to. Okay, so let's initialize the SD card library, and let's start with this. Try Larry. Okay. And then it occurs to me that this probably won't actually work because the SDMMC will not have access to the work buffer because the SDMMC driver won't be able to access trust zone RAM. So actually, I don't think that will work. And I'm going to need to map in the work buffer for the SDMMC driver. Okay, that's kind of an interesting problem. I mean, I can use the data region that I already have mapped, which should be fine. But then I need to map it into the SD card. And do I remember how to map things into the SDMMC device? Answer, no, of course I don't. It's not like I wrote a kernel recently or anything. Let's see how I would do that if I were in Mesosphere. Libraries, libmesosphere, source, board, Nintendo, NX, speed, device page table. Yeah. Okay. Because for people that are crocodile food. Very true. Fuck astronomers. Fuck astronomers. Okay. MC acid. It's going to be SDMMC1, I think, is the SD card driver. Let me verify that. Papers, source, SDMMC. Go to port, SD card 0. Actually, it'll be like here, maybe. No. Fuck, what file did I even put this in? I guess it'll be an SD card device accessor. Nope. Yeah. SDMMC1. Yeah, okay, cool. I thought it was SDMMC1, but it's good practice to check that. Okay. So we're going to need to configure the SDMMC1 ACID to point to something that is valid. And we're going to need to like set up a fake device page table for it. Everything about this is going to be like dumb as fuck. But we will do it and it will be fine. It will be totally fine. So if I were going to actually like set up a device address space, ignoring all this shit, the ACID values no longer really matter here, I think, because we will have killed the main CPU. So I'm just going to need to create a device page table. And what I really want to do is I just want to map the start. Okay, let's think about this intelligently. From the secure monitor's point of view, we're going to have the buffers that we want the SD card to be able to access. We're just going to use the like DRAM storage region, which is fine. Because that's like the bit of reserved DRAM that the secure monitor can access and nothing else can. Storage, secure DRAM sec. Okay, yeah, there is. And that is 0x 10,000 bytes at 1F01. 1, 2, 3, 4, 5. Okay. Unfortunately for us, this address is not valid for the SDMMC device, I think, because it doesn't actually support high support address spaces, which is unfortunate. I would love to direct map it, but I don't think that I can. Oh, no, actually we can. That's a valid address. Lit. Yeah, okay. We support high support. So 1F0100,000. Great. We can map that address. So we want to map this memory at this address. And this isn't aligned, but that should be okay. So the first thing that we're going to want to do here is we're going to want to actually map it in. So let's add a void map main memory ORSDMMC1. Why wouldn't it be okay? Some devices don't support 34-bit addresses. Most devices are actually 32-bit addresses, and some of them are 34-bit. And Thyron, I usually use apostrophes for normal numbers, but I don't use them for hex. I prefer not to use them for hex. Just, you know, maybe it's just me being an idiot. Yeah, I don't know that I prefer that. I like counting the groups of 4. Even if it is, you know, not actually intelligent, I think it is my preference. Okay, so what is the device page table format? We need a page directory, and then we need an actual page table. Great. You like counting to 4? Okay, it sounds really stupid when you say it that way, but yeah, I do like it. So I guess we will just use the last pages of this region as device pages, because that doesn't actually matter. I mean, we can use anything and it's all the same. So what does the process of creating a device page look like? This tables, L0 index, address, over device region size. Device region size, I think this is like a gigabyte. Yeah, okay. I'm just gonna, you know, real quick. There should be its own file. It really should. So let's make it its own file. Atmosphere, exosphere, fatal, source. Fatal, device, page table. I am so glad that I make that stupid joke. Initialize device page table for SDMC1. Okay. Yeah, impromptu refactors are fun. Fatal device page table. Okay. Long singular. Yeah. Okay. That's that. And then let's copy all this shit in from Mesosphere. Now got that. And then what else do we need from Mesosphere? The only device that we care about is SDMMC1 acid, so we won't bother with this. We don't need this either. We don't need the HS devices. We don't need this. We don't need this. We do want this. So let's do the old copy paste Rooney. And yeah, this should all be fine. Should all be fine. And then we're just gonna do, you know, and UN. Physical address. This prevents the compiler from reordering around this statement. That is, it cannot reorder the instructions that write this around these two barriers, which is important for like setting page table values. You don't want them to be reordered because they're sensitive to that. And if we like reserve the first 3 acids, that's fine. We're gonna use acid number 1. That's my feeling right now. Let's expert. Wait. Say 1 acid is 1. Cool. And this is all fine because this is a reserved acid already. Although actually, we don't need that. The reserved acids should just be these. So we'll use that directly. Let's expert. Let's do 8 reserved acids. First vaping, then acid. That's a good joke. And we will do this again. You know, it's nice to just have the same abstractions. Reg writes. And I have MCXs in like another file, so let's copy paste from that. Sphere, program, source will be in setup. MC. Really? I don't have memory controller rights in this file? Surely I do. MC, I totally do. Yeah. Right, there's a bunch of spaces. Should we be concerned about careless copy-paste mistakes? Yeah, probably. I'm sure that I'll make mistakes here. It'll be fine. Doesn't really matter. Okay. Reg writes, MC plus offset value. Then here we will do return reg read C plus offset value. Okay, and then what else do we do here? Yeah, this is like our interrupt logging. We're controller utilities. Yeah, let's just, you know, copy paste all of this shit. There's no reason for us not to have it. Set table for an acid, physical address. And we're not really using k physical addresses because we're not the kernel. So these will just be dd physical address. Yeah, I'd rather just, you know, get all the like logic out and then fix the stupid mistakes afterwards. Also, I don't need these mesosphere asserts. It's fine. Everything's fine. Yeah, I guess I can leave them and then have them be in mesosphere asserts becomes AMS assert. Is not physical address. Do I have that? No, I don't, so I don't want that. But I will keep the alignment things. The alignment checks are useful. Okay. Okay. This should be good. This will write stuff the acid. This will do that. Great. And then what do we have here? Do I actually even have a map here? Is this? Yeah, I think I do. Great. Great. What else do I need here? The kernel I've already initialized this, so I don't really need this. Reserved acid. Okay. Okay. So the first thing we're going to want to do is we're going to want to set the acid to our desired one. And I guess I will do the first thing I was going to do. STMC1 acid is, let's make it 1. It's a good auspicious number. Okay. So, yeah, I don't need this lock here because we're not the kernel. DD physical address. Great. Okay. Okay, what do we want to do here? We want to do set table for the acid. Then we're going to want to map the region into the acid. And we're going to want to, no, I think that's actually it. That should be everything. Those are like the two things we need to do here. So, okay. How do I do this? Ensure consistency. Yep, that seems right. Table for the acid is going to be 80, and then yeah, okay. I'll copy this directly and edit it. I understand this. LU is table count defined here? Where is that defined? I think that's a device page table member, but it's 4. Yeah, okay. If you guys can hear the traffic outside, then I think my mic is probably fine. Table count is 4. I'm just gonna hard code that. It doesn't matter. Context B34. And we're actually gonna do this above because it's a constant. Better. Context per. I guess I don't actually need the inline because these are in a translation unit. Context per U2V2, STMC, acid value. That's confusing. There's the value. Okay, now let's take this shit again. I wonder if you guys can hear the like cop car that's outside right now. Value is this, and device name, we know it's supported, so we want this. We want to do this. Yeah, sorry about that. I mean, I obviously don't have control over, you know, cop car noises, but I apologize nonetheless. Okay, so this will get value, and then we will do this here. And the acid, actually, there's two things. There's 3 things to do. First thing is configure C use new page table, and that's what this is really. This is a different thing, which is still to do. And this we can hard code. It's 1. Yeah. This STMC acid register value. Okay, so that should initialize the acid to the right value. And then what? Then what? Then what? Then what? Yeah, it's attached stuff it's whatever. And we don't need all of this tracking stuff that the kernel uses because we are lazy and we only need to do this once and this isn't generic. You just attach value. Okay. So now our table will be used for everything, which is great. And we're starting some index here. I see. So when we initialize a page table, we allocate tables for all of the regions, and then we set the tables. And I think we only need 1 table because we are only mapping a very small region. So let us, save us some hassle and add these to the memory layout. Where's the secure data store? Let's say that constant experience line, const region memory region virtual DRAM SDMMC1 device page table. This is the L0. This is the L0 table. Let's make this the last page for simplicity. No, F. One page, and similarly for physical. Physical, it'll be 1000, and it'll be 8001 F1000. Great. Okay. That's more defines. DB address, DMC, L0 page table. Yeah, the way that I read hex is a little weird, but don't worry about it. It's fine. And then what do we do here? Okay, we're going to want to clear the table and flush cache to it, I think. So let's physical, and let's make this a spare void star, maybe? Yeah, this might need to change later. Let's make this virtual. Let's make this a pointer to void. Okay. Let's clear the L0 page table. Set 0. And device page table size should just be one page, I think. Do I want to assume that? Yeah, it's fine. It's totally fine. Device page table. Hey, Masan. I'll also need to change these because I just updated their names. A100. That's pretty good too. Okay. Commit the page table and flush it. Flush data cache. Okay, what next? Want to actually attach the space, and yeah, set table for this. Okay, great. Table acids, user address. Got it, got it, got it. This should be fine, I think. Will this work? I think that it should. Yes, everything is going to use the same acid. So I guess we're actually mapping the same page at a bunch of addresses, but that seems fine. I can't imagine any problems for that. So let's do it. acid. This will be SDMC L0 page table physical. Okay. So now we should have an L0 table and it's mapped. Great. What else? What else? Is our address-based thing actually right? Because device region bits is 32 bits. No, yeah, that's fine. It's totally fine. Is it a common situation in loading main SSO that gets unreadable method and class names? I'm not sure what you mean by that, but yes. Does cache work on physical addresses? Cache works on virtual addresses, ML, not physical. Because I'm doing like a CPU flush by virtual address function here. This is like, this will compile to a bunch of DC civics taking in the virtual address. Also, there shouldn't be a 0 argument here. Better. Okay, map. This calls map impl, and what does map impl do? It's been so long since I wrote this. I wrote this in July. Why do I expect myself to remember things from July? And we only want to map, let's say that we map the lower 8 pages, I think. So let's write our map impl. Let's make it a void because we don't want it to ever fail. Void map impl. And we want a device virtual address, which I think is just going to be UN pointer T. That's fine. Mabel device virtual address. The permission, well, our permission is just always going to be read write, so we don't need that. We need a device address. We're using a page group here, but we can just use our virtual address NSIs. Although, these are really physical addresses, so let's do physical addresses. When I said map's the same thing, I was talking about for the device. This is flushing the data that we just wrote from the CPU, and the multiple mappings are for the SDMC device. Okay, so our map will take in a DD physical address scatter, T size, and a, let's call it use54 device virtual address bits using device virtual address. Yeah, device virtual address. Device address. Yeah, Rage Quit. There is an assumption, since we're in the secure monitor, that the other cores have all been halted, and this is only ever going to run on a single core, and the other cores are like spin looping. So we do not need to care about concurrency at all. We are totally good from a concurrency point of view. Okay. What do we actually do here? We check that it's free, but of course it's free because we are only ever going to call map once. Iterate mapping device pages. That's the only thing that we actually care about. Address here. This we don't really want. This we want ti equals 0, I is listed size, I equals. Do I have page size? Probably not. Let me check that. Sphere, libraries, libaxis sphere, include will be in hardware. Hardware ARM64. No. Check here then. Be an MMU. Excellent, we do have it actually. MMU API. Do we have it? Page size. Excellent. Okay, so we have access to it via MMU page size. And it is, of course, a heap virtual address. And the physical address through the page is just going to be is header plus I. map it, and the block size is, you know, 1 page. Does map device page actually support more than one thing? I bet it does. Oh, it totally does. Okay, great. We don't need to do any of this then. Void map device page. Actually, since we're only mapping a single region, we don't even need this. This can just be map device page. I mean, okay, sure. I forget that I operate on groups normally. Yeah, this is all fine. This is all fine. Cache permissions. Spool read. We want the device to be able to read. We want the device to be able to write. And then we're gonna have all this walk the directory shit that we are going to mostly like excise, but that's fine. Don't worry about it. We like know we're only. Did I copy paste too much? No. What's this then? Will remain as 0. I just didn't indent it. Okay. Don't need this anymore. And I'm gonna need to change this, but it's fine. What is the address argument here? Is that a device address and fit address? Okay. Okay. Got our indexes, and we want to get L1. And I guess this is really going to be, we don't have get pointer anymore because we're no longer in the kernel, so this will need to be interpret cast page directory entry. And the L0 index. This is super shitty practice, I acknowledge, but we're going to use a single L0 table, and that'll be fine. It'll be totally fine. STMC L0 page table. Great. SP assert. Make all the message asserts into AMS asserts. It'll save me some hassle. Okay. And then what do we do here? If the L2 index is 0 and we're aligned, do we make a large size? Yeah. Flush data cache. Yeah, that's fine. That's fine. That's fine. That's fine. We don't do reference counting. Great. Otherwise, if an entity, we are not doing limited page tables the way that we do in the kernel. What are the drawbacks? It would break if I was doing like more than one mapping, basically. It's shitty. It's not something that I should be doing, but it'll work, and this doesn't really matter. So we're doing it. Make an L1 table. Yeah, we're also going to use a single L1 table. I mean, you know, we don't need more than one L1 table. It'll be fine. The L1 device page table will be at this address. Yep, that's my story. I am sticking with it. Void. Okay. See a one-page table. Good enough for me. Yeah, exactly. This is like fatal error stuff. Like, this is the single place where it makes a lot of sense to do a bunch of lazy bullshit. Also, I think that I can do a static cast here. C++ lets me do invalid static casts, which is nice. Okay. The L1 table. Let's clear the L1 table. Memsets. Let's see. What did I call the table down here? L0 page table. Just copy paste this. Let's make that L1. great. And then the table address here is going to be L1 page table physical. And we're going to want to flush the cache on it. We will again synchronize here. STMCL0 page table is a void star, and you can static cast void star to anything, so it's fine. Table acids, and the table acid is always STMC1 acid. DMC acid. Yeah. Okay. Cool. I think that should map the L1 table. One is a table, great. And then this is going to be static cast, page table entry. This will be STMC L1 page table. I think so, yeah, because this was, oh, it's L1 at L1 index. So I guess this is actually just going to be, get virtual address of L1 index.get physical address. Oh geez. No wait, L1 index is what we saved here, and we know that the physical address here is page table physical, so it is the L1 table. So yeah, that's fine. Totally fine. Meaning entry, yep. Map count, yep. We assert that it's valid, and we set the page to this. It's fine, we don't do page reference counting. This is going to be hardware flush data cache. Yeah, this will work. This is just going to be validation, table acids. This is again going to be STMC acid. We don't do page reference counting. And that should be that. Okay. I don't think this is spaghetti code so much as this is me just taking a bunch of shortcuts. Map the appropriate region into the acid. Atmosphere is a terrible S factor already. I wouldn't worry about that. STMC mapped data. This is going to be here. We're going to map in little bytes. Then we're also going to do physical for 1000 bytes. Cool. So now this should map in all of that sweet memory at the address that we want. And so now our virtual address for the CPU will be the same as the virtual address for the STMC device. And with any luck, we will now be able to use a work buffer there, and things will just be Gucci. So let's actually pass arguments to map-impl. Map-impl takes in a physical address, a size, and a device address. So let's give it a physical get address and this dot get size, and then the virtual address. And do I do anything after I do map device page here? Map device page. Possibly. I might do a SMMU bullshit, but I think it's probably fine. Map-impl. No, I think it's just handled internally. Yeah, okay. We're good. Okay. I think that is page table code. Now it won't compile because there's no way I just wrote that much code and it compiles. Nissan, don't worry about that. I absolutely do. It's just hidden. If I go here to Exosphere, and I go to Program, and I go to Source, and I go to Boot, and I go to Make Page Table, the function that makes the page tables is constexpr and takes in these things. So this is all constexpr, and then I have this constexpr bool, which is validate TZRM tables, and I statically assert that there are no conflicts in the tables that I build. And this is important because I use a single page for L1, L2, and L3, and so I had to carefully design the address space so that there were no overlaps in any of the entries. for all levels of the table. That was more effort than you'd think, but it works. Okay, this will not compile. It's gonna build the like libexosphere first, because I edited the header. Yeah. And this will obviously not work, but we just care about it compiling right now. Yeah, I would be very surprised if it compiles. It really shouldn't compile. Yeah, okay, there we go. That's what I was expecting. Great. So let's see. Where did we fuck up? I'm sure lots of places. Really? This again? Ah, right, because I have to do make debug. Okay. Give me those sweet errors. Thank you, chef. Page directory size. Page table size, yeah. That's obviously not a thing. We'll make that MMU page size. Static assert it is equal to page size. We don't really need the page static assert, but we'll have it anyway. 3 size. Okay, that's that's just it complaining. Let's see what that fixed. What next? What next? What next? Did I scroll up too much? Looks like I did. Okay, well, I'm lost. Fuck. Okay. Static assert. Really? Device page size, that's the later line. Page size. Okay. And then call the non-const expr void. Yeah, I guess that I can't turn an address into a pointer at compile time. So this is just going to be constant void star const. Good enough. Get integer on address. Yeah, it's a kernel thing, which I didn't fix here. This should just be adder, because these are integers now, and they're not like my special wrapping types. Okay. Then what on 148? We're doing something wrong. Oh, right. Invalidate PTC, it's declared void. Why is that a problem on line 160? Oh. Take in a physical address now and not a kernel address. Address, cool. I'm sorry, I'm now. Okay, device virtual address, that's on line 171. Yes, it's gonna be DD. Address. It's also DD physical address. And 223, yeah, we have the same like get integer things that just aren't needed. Integer there. And 229 we convert to a virtual address. Oh, this is the same thing. This is get the physical address of the L1 address. And L1 index is guaranteed to be the L1 page table. So this we will just do that. Then I'm missing a semicolon here. Invalidate PTC. Did I not copyright and paste the right PTC function? Validate PTC. Oh no, right. This is just because the PTC had the wrong type, so that's actually fine. And 273. We have another like k-device virtual address thing. Where this is, you know, LAPTC. Okay, the address of L2I. So L2 is the table, L2I. So I guess this is just going to be. I don't want to do this. This is clearly STMMC L1 page table. Physical plus, and then I guess this is I times size of page table entry. Is that true? Yeah, it is. Is L2I? Yeah, okay. Then on 301, I'm also missing a semicolon there. And that's, I think, all the issues here. I mean, I'm sure that I fucked up more, but let's see. Great, thank you. May I have another? Okay. Constant is not a... Fuck you. This is absolutely a constant initializer. I mean, I guess that this is not context fair, but like, come on. Is it... Fuck you. Whatever. Now, you know what? It's fine. I am not having this be a manifested variable in RW data. That's bullshit. This is going to be a constant. Ugh. Nope. I don't want to touch the physical ones, actually, so let me be careful about that. Okay. There, and there. No, it's not that it's not constant, it's that it's not a constant initializer, which means that it can't be evaluated in the context per context, which is true because you cannot turn an integer into a pointer at compile time. And then similarly, this is going to be the L1 device page table like a pointer void. We're going to delete this, we're going to delete this, and we only want to touch the virtual ones. Virtual, physical, virtual, physical. Okay. Why code with Notepad++? Because it's the superior way to code. Nice. Nice. But I know what's causing that. That's actually kind of expected. This is like sec1 error that I do this. I just need to like have an abort impl. So let's go ahead, do that. Fatal source. Fatal abort impl. This is namespace diag. What we really want to do here is infinite loop. On log abort impl is called. And if this like actually starts happening, we will tactically, very tactically, begin doing things the right way. I probably want like a backtrace and shit here, but I don't need to worry about that yet. Not yet. And now we're missing host controller, shutdown, put to sleep, and awaken. How am I missing those? That one confuses me. Shutdown, put to sleep, and awaken. How is that possible? Because if I go to libraries, live vapors, source, I'm gonna go to CMC, check out iHost controller, sleep and awaken, etc. Shut down, put to sleep, and awaken. They're not like abstract. If I go to iHost controller, do I not actually have those? Dash R, sleep, or iHost controller. Interesting. These should just be equal to 0. Wonder why that was not failing for my test program. Because iHost controller is abstract. It doesn't have anything. Okay. Let us try this again. Yeah, I guess let's try to manifest the table here. Cool, that built. Great. We did it, Reddit. I mean, this is just not going to work at all. And let us say that the work buffer is at the start of the little region we have. Actually, it's going to be 1 page before the end will be the work buffer. That's reasonable, I feel. Where is my little page here? Secure STRAM map data, yeah. Always inline. Wait. Get SD card work buffer. Turn. Weights plus dot get size minus new page size. Okay. And the work buffer size is going to be this. And we'll do get SD card work buffer. Okay, that might do what we want, possibly. And the good news is I can add logging to all of this if I need to. That should be like totally fine. Then let's go to libraries, lib, LBXsphere, program, source, or no, not program, fatal error. And CMC. That's actually probably initially the Steam. No, that's right. Okay. Going to be okay. That should be that, and then here, going to want to map this is going to want to include fatal device page fatal. And to initialize the white space table for STMC1. Great. Great, great, great. Okay. I think that will do the thing that I want it to do. Possibly, maybe, who knows? It's not impossible. Why is this going to fail? Think about this in advance before I run it and it fails. Okay, it's going to fail because the STMMC driver accesses devices using like a query virtual address API, and I haven't hooked that up for XSphere yet. So, let us fix that ahead of time. Vapors source STMC rep. Okay, what do we need? I forget how to use trim. It's fine. Okay, we need GPIO, we need APB, and the actual registers themselves. Okay, also clock and reset. So that's fine. Clock and reset, STMMC, GPIO, APB. I think Secmon has most of those already. Let's check that. We have APB MISC. Yes, we do. Great. Do we have GPIO? We do. Excellent. Do we have clock and reset? We do. Excellent. But we don't have STMMC because nothing has used it before. So what do we actually query for STMMC? Where is the line that's actually querying that? Registers address. It's in... There's just phys-adder. Okay, it'll probably be in the Tegra device accessor. Hello, Mary.sh. It is always nice to see names that I don't recognize. STMMC1 is here. Great, STMMC1 is the only thing that we care about, and it's at 7,000 B1000. Although the STMMC, I think, are all in the 7,000 B range. Oh. Okay. Mary, is that Thog then? Question mark? I was going to guess. Nice. Okay. Cool. That makes sense. I am unused to seeing your name not be Thog, but I will keep it in mind. Sorry for the confusion. Yeah, okay, the STMC registers are at 7,000 B1000, and they're all in that page. So let us quickly add this extra device here. STMMC. Which comes after memory controller 1. And it is at 700B000, I think. Yep. And it is one page, and it is secure. Yes, I think. Yeah, let's go with that. I don't even remember what the secure thing does. Really, what does it do? All right, that's just the mapping that we do. It's fine. Whatever. Okay. So that's that. And then we need to hook up the stuff that might get queried inside the DD query logic. Gray mapping. Great. Secure monitor translation. Do this in a less shitty way. So we're going to je ne sais quoi, take a shortcut. Region physical device, and we want clock resets. Switch. scatter. Reset.get address. Want to return the corresponding virtual address. Region virtual device. Reset.get address. Okay, and this is also a secmon thing. And then we want to do this for all the devices we care about, so that's going to include the GPIO. Though actually, this isn't the best way to do this. Ugh, fine. If let's see, what is the type here for this thing? It's secmon : memory region. Yeah. Okay. If this dot contains is address size. Let me check that that will actually work. Start address and address plus size -1. Yep, okay, that's exactly what I want. I want to return this. Address plus is addr minus. Okay, that should actually, I think, work. This will be the else case. And then you're going to want this. And then this is going to be, I also care about GPIO, clock reset, GPIO, AP BIMISC, SDMMC, if I remember right, probably. I don't need it to be else, but structural similarity, it's the preference. AP BIMISC. BIMISC, and this will be SDMMC. Okay, I think that's functional, probably. Will it compile? No. It does compile, great. Great, great, great. Great, 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 great. And let me turn my console back on and get to a point where I can copy stuff to the SD card again. Because we're now at the point where it makes sense to run this, I think. I'm not aware of anything that would break it. I mean, it won't work, but the first step to making things work is running them and seeing why they don't work. And I no longer have any reason in advance why this wouldn't work. Probably had this earlier. Cool. Okay. Let's launch it and see what happens. Okay. Cool. So an exception occurred, which is fine. An exception means that my code jumps to the exception logic in normal exosphere. Oh no, that's just because there was a that's fine actually. This is because it did a reboot, which cut off the printf. It's actually totally fine. Totally fine. So let's add some logging to Fatal. Why not? Program, source, secmon error. Because this is what's happening, basically, is the exception handler is executing, and an unknown exception, which is what's happening, is we are setting the error info to this, and we're just doing an error reboot, aren't we? Okay, we're gonna do some tactics here. Where we're gonna like write a real exception handler here, and that should be fine, I think, probably. Okay. Exception vector. Let's make this an if-def. Let's do if find AMS build for debugging, find AMS build for auditing, else, and if. And in the case that we are in debugging, we will jump to the debug exception handler. This is going to be a branch to Z N3 AMS 6 Secmon 16 exception handler EV. Is that a problem, MVL? I mean, if defined this should only happen in debug mode, right? Because this is an OR. What? I think this is fine. Question mark? Oh, no, I don't like that. I way prefer the defined thing that's, you know, explicit. Okay, so what do we want to do here in our exception handler, since we should like actually write an exception handler? So let's make a new file for that. Exception handler.cpp. We don't need this yet. We'll probably want it on a namespace, but we don't need it right now. And then return void exception handler. Okay. And yes, we will want to reboot afterwards, and we will also want to do the same thing here where we set the input unknown abort. And that'll be fine, I think. Yeah, great. Okay, so yeah, we're gonna want the link register and stack pointer. Get link register and stack pointer. Cool. So that'll get us those two. And then do we use atomics here? Okay, yeah, cool. And I guess we're gonna want to include error. Dude, I love Notepad++. It is my ideal editor. Is function preamble not going to trash LR? Why would it trash LR? We have taken an exception handler, and we used a B instruction, not a BL, so that won't change anything. And X30 doesn't get set until we call a function, so as long as I do this before I call a function, it's totally fine. Okay. Else, we're going to want to acquire this. Where was my little grep from a second ago? Grep HRG is locked. Okay, do I want to do a compare change strong? No, because I don't want that to fail. And so what I really want to do here is okay, we're gonna look at the C++ atomics reference again. C++ atomics. Oh, also that reminds me. I don't know if anyone here is interested, but I realized that I had this design document that I use for Exosphere that I documented its memory layout that I use to make sure that I don't fuck anything up. And I had never actually made this public before for no reason. But this is very typical of the design documents that I make for myself. And so if you have any interest in what my like internal design documents look like, this is super typical. And I just threw it in the documents because it's interesting and there's no reason to keep it private. When I was editing it, when I was adding the new layouts. Atomic. What do we want? We don't want to do a compare exchange. We just want to exchange, I think. Yeah. Great. We want to set it to true, and we want to get it. And so we set it to true, and it was false. So, require exclusive access to exception handling logic. Oh, G is locked. Dot exchange true. Let's wait a bit. Get access. Wait microseconds. Oh, wait a millisecond. A millisecond is plenty of time. And then before we want to reboot, yes, we want to change it from false to true, and so this will return false if we just got access. Yes, this is right, I think, probably. I was going to set it false before I reboot here. I guess I don't really need to. Yeah, you're right. No, it would be nice. It would be nice for this to work. No, a reboot will happen. Yeah, okay. Okay, that'll do. And then we're probably gonna want some like assembly magics here, I think. Because otherwise shit's gonna get really trashed. So let's invoke the exception handler info. And that will do. And we'll also have a void exception handler impl. And we'll do invoke exception handler impl. Got it. And this is what do we want to take in here? We want the link register and the stack pointer, I suppose. Is that true? I think so. Then we're also going to want these as arguments here. Although, actually, do I need to do any assembly magic? No, I don't think so. Right? Because we've got the stack pointer from here. Yeah, I don't think I need this. Great. Okay. Now, let's take this, and then we're going to want to put it in the debug code region. So where is my debug code? Let's do this and copy paste more than I need here. And I don't actually want all of this. I only want like one of them. Row data. And we're also going to want .debugcode.bss. Debug code in the glob. Yeah. This will be, since Secmon main, this is going to be Secmon exception handler, and now this will manifest inside the debug code region, which means it won't eat up space in the proper secure monitor memory. Great, that should be good. And then what do we want to do here? What system registers do we have access to? Include LB and libxsphere, libraries, libxsphere, include exosphere, hardware. Does it make a difference? I have no idea, but I'll remove it just to be safe. Thank you. Okay, cool. We have all of it. We have all our defines. Gets this reg, yeah. Yeah, link strips are super fucking touchy. And I no longer remember, so you can hear my neighbors like going through the trash or something. I no longer remember how my getter works, so we're gonna do a quick and casual our hardware CPU get. Okay, we do it in cache impulse, so that's a good place to check. Yeah, okay, there's like this thing where we do it via ASM, which is always a little weird. But it'll be fine. So what registers do we want to print? ELR is obvious, as is far. And then we're also going to want other stuff. But let's start, hey thanks. Let's start with far and ELR, and we can print more stuff as it comes. And ESR. ESR is good too. Far EL1, and pointer T, far EL3, ELR, EL3. And then let's also do U32 for ESR L3. Then let's do hardware CPU. Do we have far here? We don't. That's fine. We'll just add it. That's the good news about this. This is really easy to edit. Get far L3, far L3. Do we support getting far L1? Probably not if we didn't have far L3. L1. Okay. That is fine. We will put that down here. Far EL1. And ELR EL3, I'm sure that we have. I mean, I'll check, but it would really surprise me if I didn't have a getter for ELR. Damn, we really don't have ELR EL3? How have I never needed that before? ELR EL3. Oh yeah, probably. Far L1. Wait, what did I miss? Far L1, far L1. Far EL3, far L3, ELR L3, ELR L3. Thank you. Much appreciated. And then I want ESR EL3. Please tell me I have ESR. How the fuck do I not have ESL? That's bullshit. Why do I not have it? It's total bullshit. But okay, fine. ESR EL3. ESR EL3. Okay. Good. System registers. Okay. And then, what else are we gonna want to do? We're gonna want to print stuff. Slug. Let's make sure that we've got. ESR %08x L3. And we're gonna want to extract the ESR fields. Do I at least have that for ESR? Please tell me I have that for ESR. Past self, what the fuck are you doing? Struct ESR L3. Actually, I guess I'm gonna want ESR to be a util bitpack. No, I didn't do that yet, thanks. But it's fine, I don't need it yet. Because this is not in the boot code region. So if this like eats up a bunch of space in the normal region, it doesn't matter. And I think this is gonna need to be dot value. It's a bitpack now. No, it's 32 bits. Okay. Let us open this up. And then we're gonna want to find the ELR register. God, where is this? Really? Are my links broken now? I could have sworn that they were right. Okay. Search ELR EL3. Great. It's like these are for different boards. And Cortex 57 is DDIO 488. So if I just edit that, will that work? Oh, it's redirecting me to the processor manual. Why is that a redirect now? That sucks. Okay. Okay, where do I actually download this next section? Do they not contain register descriptions here anymore? Whatever, this is probably fine. Probably. Sorry, L3. So guys, the EC is bits 26 to 31. Using EC is util bitpack 32 field 26, and that's 6 bits, I think. 26, 27, 28, 29, 30, 31. Yep, that's 6 bits. And yeah, it's that. And then there's IL, which is bit 25. I don't think we really need that, but we'll include it using IL till bitpack 32 field 25 1. And then what else? There's ISS, which is bits 0 to 24, so it's 25 bits wide. Okay, that should be good enough to access ESR EL3. And then what? What do I need to do here? log. What are the real names for this? ISS instruction syndrome. Yeah, I'll take these in order. Description class so 2x ESR3 dot get, and let's make these U32s instead of ints. Although I think U32 is the default actually, so no, that's not needed. Dot get. This will be, I think, CPU ESREL3, or just hardware : right? EC. Okay, I think that'll work. Then instruction length. This will just be %d. Instruction length. Fuck, god damn it. Not what I wanted to do. I think 1 is 32 and 0 is 16. Okay. IL. And then there's an instruction syndrome. Specific syndrome. And I think this should probably, how many bits is this? This is 25 bits, which is 6 plus 1 nibbles, which is 0.7x. ISS. Cool. And I should probably like print out the name and shit, but I can do that later. Doesn't matter. And then let us just log the others. REL1 %16LX. REL3, DLREL3. Thanks. AMS secmon log is AMS log, but it prints secmon before. Thank you. And that will do for now. Let's also print out the link register. AMS secmon log. LR. 16 LX and LR. Let's make this all nice and aligned. And then SP, same thing. Okay. Let's also dump some stack. AMS dump. B. Yep. Line up SP and view page size minus SP. Cool, and that'll dump stack up until the top of the page. Nice. Okay. Then let's 16 debug, copy exosphere debug.bin to E exosphere. Okay. Also, obviously, at the end of this, I'm going to want to do an AMS log flush. Or is it log flush or flush log? Might be flush log. Yeah, a little bit like this. I am entirely confident that this is not going to be a Stack Overflow Mason. The code that this is executing under is a has an OX8000 stack, and I'd be really confused if I used up more than 32 kilobytes of stack. Exception and level. SP. No, I don't have BMC here. Yeah. And actually, let's do a log flush before we do this too. And that way, whatever we were logging before won't be like cut off in the middle or get interleaved or other gross shit. Expected symbol, MS Segmon exception handler. Interesting. Oh, it's going to be because this is in a different section. Right, because this is debug code, and we can't do a jump to a different segment like this. Well, when in doubt, load x16. Undefined reference to AMS Segmon exception handler. Interesting. Interesting. MS Segmon. Oh. So. Yeah. Okay. Now let's give that a whirl. And we expect this to print stuff now. Did I break things? It looks like I broke things. Interesting, because Exosphere is no longer actually booting stuff. That is unfortunate. I guess that it might be the SDMMC mapping. Oh, you know what? Why am I even questioning why the exception handler happened? The exception handler happened because I didn't update Exosphere to map the SDMMC registers. I wonder if I'm overextending my map. Let's check out the memory layout here. See. These will all have guard pages in between them. I wonder if I have used up all of my device mapping space. That seems plausible. Although this verifies that it contains, so that should be fine, actually, I think. Because I reserve enough space for the devices, I think. Yeah, I reserve 40,000 of virtual address space for them. It's at 1F1004,000, so let's check that against my design document. Docs, components, detail. Yeah, that should be totally fine, as far as I know. And the fact that it's building means that there are no static assertion failures. Could be something in the link script, possibly. Okay, well, we're going to open an item. We are not getting to the Ohio, so something is going wrong early. we know. Did I delete a bunch of stuff on the ship? I didn't think so. Like, T0 and boot code is still here. I like copy-pasted stuff and then deleted it. I thought. This should all be fine, I think. Hemisphere, exosphere. I don't think I need a diff, but I am going to open this NIDA. Okay, what does our page table setup look like now? Something's going wrong here. Then it's probably early, I think. Yeah, it's clearing. Boot code high. Okay, that's its own thing. So it'll be fine. So we're not getting to this point, which means that there's very little that can go wrong before you. It's basically just page table setup that can go wrong before this point. I mean, I guess that I can check the logging API. Libraries, Exosphere, source. No, the logging is still working because we didn't change that since, yeah, no, it's fine. Okay. We're not getting to this point. What does it imply? The code that jumps here is in here. Second on starts. So that does that is here. This is all super like normal. I don't see any way for this to go wrong unless, you know, like the page table setup is fucked. The memset veneer is fine. Huh. 1B, it's adding it, okay. Where's memset? That should be fine. Because this is only being done after we have set up the page table. So we know that this is fine. What is going wrong in make page table? Okay, that's fine. Okay, this is where we're mapping devices. We map this here, and this is not overlapping with anything, so that should be fine too. That should be totally fine, I would expect. I wonder. I don't think I changed anything that would have fucked up early boot. I guess maybe the stuff could be too big. Let me look at the loader stub. Atmosphere, exosphere, loader stub. Look at that. Zero. I mean, that really can't go wrong. Libc init array. Oh, I bet I know what it is, probably. But let me check this first. Yeah, it's fine. Press and execute. This one will be fine, but we are eventually going to call init array, and I bet that I have an init array now, and I didn't before. Yeah, this is fine. This is program uncompressed. That should be fine. There's no way that's gone wrong now. Yeah, okay. So let us look at init array. libc init array. Init array. Where is my init array? Huh. Never mind. I thought that this would be... I guess I still don't have any init array functions. Never mind then. Yeah, now, this is going to memset these regions, but that should be fine. ECO to, yeah, no, that's fine. And then we call main. none of this can go wrong, and this really can't go wrong either, because this is just like really basic init. Yeah, I don't think that can go wrong. Okay. How do I debug an issue that occurs before I gain the ability to log stuff on Mariko? This is one thing on Arista where I like have like reboot and read IRAM, but I don't have that on Mariko. Let us make the questionable assumption that there is nothing wrong with the loader stub and that it is still functional. Is that likely to be true? Look at what I did to the link script. I added this segment, which could possibly be messing stuff up. Possibly. No, Finks, I don't want it to be no load. Remember, I need BSS to be loaded, because this needs to be in the physical binary. It's the same thing like here. Like, this must be loaded. It must not be no load. It's actually very important that this is not no load. Like, if this was no load, it would fail in exactly what I'm observing. Which actually, I might just need to delete this, but... Hey, Malika, doing pretty well. Let's actually look at the debug code region. If we go to .debug code, we'll see we've got a lot of stuff. Printf, and then we're gonna have the exception handler probably somewhere in here. Yep. And we have 4 bytes of BSS. So let us check that those are actually there, because it is really critical that they are. Because that could absolutely be the problem. Program. Where is this going to be? Program debug.bin. Let's look at SP. Alex. Yep. Okay. The problem is that BSS is not manifesting. God damn it. God, that's annoying. Okay. How am I manifesting the BSS and the other things? Because I need them. Right. Like, I need to manifest BSS or reify it or whatever you want to call that. Oh, I see. I see. I have this .fill, which is, solving my problem, basically. Yeah, Think spelled it right, reify, R-E-I-F-Y. Okay, the fill makes this work for me, and I'm just going to need to do something like that. That'll be fine. Debug code .fill. We're going to want this to be origin plus length. Okay, and that, I think, should work. And that should mean that everything after debug code will be zeros. Yeah, but that's just because you're wrong, Finks, and I forgive you. Now that BSS is reified, let us try once more with vigor. Okay, come on. Nope. Nope, nope, nope. Is that messed up? Oh, I bet that we are way exceeding the area that we're allowed to be in or something stupid like that. Yeah. What does the loader stub look like done with this? Oh, no, wait. We just actually didn't rebuild the program. That's the issue. Literally, the issue is that we didn't rebuild. Okay. That's easy to fix. Okay. That is fixed. Launch a must have. Come on. Huh. Okay. Really? Program debug here. There's now all these zeros, which should be right. And if I look at the debug code, it should like just be like 8,000 bytes or something totally crazy. No, this is 6,000 because it's a page for boot code, a page for keys, and 4 pages for debug data. Oh, it's off by 1? Why is it off by 1? What? What did I do? What did I do wrong? What? Because the debug code starts at the right offset. And I want to fill from the current spot to the end of the debug code. So why is that not working? You know, this -1 is correct because this is this. Like this, the fill relies on that being correct. Okay. So we know that the reason that it's not booting is because there's an off by 1 in the like output of zeros, which is just bizarre. Any ideas why that might be happening? Yeah, sure. Program build debug, program debug that map. Well, the map won't be so helpful, I don't think. Right, because we have this fill here on bootkeys.fill from there to there. Then if I go to debug code, I have this stuff, which looks all good. Then I have debug BSS, and then I have all this fill. And then I have at the right address, 1 byte to 0. Yeah, and boot code end is 4038,000, which it should be. And program start is 4038,000. So why is that going wrong? Absolute dot minus debug code plus 4,000. Well, I guess we don't actually. Boot code end is being set to the right thing. It's just not filling appropriately. Is it because I have this BSS region and What is it, Finks? Tell me. Does this need, like, not having a space? No, I don't think so. Because dot is origin of debug code plus the length of debug code minus 1. But what's the problem there? Right, the way that I fill is that I set the current address to be the start of the region plus the length of the region minus 1. This is not length dot debug code. This is length of this up here, which is the 16K thing. Right, if we look at the map, it is writing the byte at the correct address. Right? Because we're here. Oh, this byte is absolutely this BSS, which still isn't being loaded. Fuck, why is the BSS not being loaded? Why is this not a problem anywhere else that I'm doing BSS? Fuck it, like, do I have something crazy here? Yeah, no, the BSS being 1 byte explains it, but how does that not fuck up like this? How is this not exactly the same fucking thing? This is totally shenanigans. What? Do these files just have no BSS and that's why I'm not being fucked by it? Kind of. But this is different, right? Because this is normal BSS. Like, this is totally different. No, Malika, there are like 3 binaries in here for different things that are loaded at different addresses. The BSS should not be after everything else. It's very important that it be in the middle and that it be manifested. I guess that I don't have any boot BSS, and this would fail if these had any BSS values. Yeah, no, because if I look at the ELF, like, it just happens that these are cleared. Like, if I go to glob start, yeah, boot BSS start and end are the same. So this would fail if these were different, which is very funny, actually. Okay, new plan. New plan, new plan. Figs. How do I get the origin of one of these segments? This is very funny, actually, now that I think about it more. Yeah, but I don't want to make a new variable here, Balika. I don't want to have like another variable for this when I don't need one. Okay. Cool, so here's our new tactic. ZRAM boot code code.bss. That's fine. And then similarly, we'll do the code BSS. Okay. Is this not going to work? No, that did not seem to work. Did I not save this? No, I saved it. Okay. Is it not willing to make overlapping sections? That could be it. Wonder if that'll work. Yep, that works. Okay, we'll do the same thing for TCRM stuff. Cool. Now we should actually reify stuff, I think. Let me get my console mountable. Oh, right. Okay, I think that fixed it. Interesting, the classes of errors that you run into when you do this kind of stuff. Mount my SD card. Okay, that's that. Now let's see if that works. Big money, no whammies. Nice. And it is not having an exception anymore, probably because we have the SD MMC stuff mapped now, which makes sense. Because it's no longer aborting when it tries to write them. Okay, why would that be failing? I guess it seems plausible to me that we are like accessing the registers when they're in a state that's like not invalid, or that's not valid, because we are just, you know, leaving them in whatever state they were for user land. See you, thanks. I'm glad you managed to catch some of it. So let's think. Why would this be failing? I mean, I guess we can add more logging. Right, because we don't know where things are dying. Source LCMC. MS log. Initializing price page table. Initialized. This can be initialized SDMC port. Sure. And this will be activated. Hey, Dubs. Hey, I mean, you say super early stream, but it's a weekend and it's like the morning my time, and I announced this 24 hours in advance, so no complaining. Also, Emil, I guess that I guess that Big Money No Whammies is kind of showing my age, but like it was such a good show. Yeah, actually, there are probably people who are younger here. Who under the age of 22 recognizes the phrase "big money, no whammies"? Is that reference just lost on younger people? Okay, yeah. So the phrase "big money, no whammies" is from this old game show called Press Your Luck, where you would like answer these questions and then you would earn spins. And when you spun the wheel, if the wheel landed on a whammy, which is one of the like squares on the wheel, spaces on the wheel, you would lose all of your money and go bankrupt. And so the phrase "big money, no whammies" you hope that your spins landed on spots that gave you money and not on the whammies that made you bankrupt and made you have to start over. It's a really good game show. Okay. So we are failing when we are like accessing SD registers probably. Yeah, I think it was an American show. Cool. Libraries, sphere, libraries, the vapors rather, source, STMC. Let's actually, we've done a lot of work. Exo, implement start of Mariko fatal handler. Git push. Git push won't work here because I don't know my personal access token set on this. So I guess that I can't actually push from here, and I don't want to do my personal access token on this. You know what? Fine. 1 second. I apologize for this. I am copying my personal access token from my like main. Can you? Okay. Fuck. What do I even call it? Never mind. I found the file where I'd keep it. Okay. That is entered and pushed. Now let's. I apologize for that. But yeah, okay, there we go. That is that. Oh, fuck. Oh well, I guess I'll have to go cancel that. Shit, I forgot that I made it visible. Okay, well, it's time to go delete my GitHub access token. Classic settings. I swear that I'm competent. Got security. Developer settings, personal access tokens. Delete. Okay, I deleted that token. It's invalid now. I'll have to generate a new one later. My bad. Not the end of the world. Okay. But with that taken care of, let's start adding logs to the STMC driver. Size. Okay, activate import is going to go here, which is going to get the device accessor, activate it. Oh, I wonder if the issue is that this is like not having its init array called. Let me check that. Sure. I find the personal access tokens to be super convenient. I'll generate a new one after this, and it's fine. But whatever. Libraries, atmosphere, exosphere. fatal elf. Is everything being inlined? What? I'm confused because this binary clearly prints stuff. What? Oh, that's not the debug build. I was printing the release build that I did way before I added any of that code. Okay, that makes a lot more sense now. Great. Start. So we'll call fatal initialize. It'll memset BSS, which is good. So starts here, so all of this will get memset to 0, which is great. And then an array will be called. And there are 3 functions in an array. And if you look here, the SD card 0 port, this should set all of this stuff. And I mean, this is all being executed, so that should be fine. Standard controller, this should be fine. Yeah. Wait, why is that happening? Nice, this is doing like a sum. What is going wrong with this dhost standard controller? Why is it not setting the registers? Did I fuck that up? If I look at atmosphere, libraries, vapors, source, system CST host standard controller. It's just enter. You have to find, oh. Right, okay. Sure. Okay, let's try this again. That's a silly mistake. I don't know how I fucked that up. But that should have been an exception. And that should have taken us to the exception handler. So is the exception handler not executing now? Because that could explain that. I'll check that out if this does not give an exception handler, but I bet this will work a little better now. I think that there's still an issue with the exception handler, actually. Because otherwise it would have printed stuff. That issue should have caused a data abort. No, I use Windows Credential Manager, TurtleP, which, I mean, it's not like the most secure, but it works for me. And so I never have to enter it. It's just saved and cached. This is just a VM, and so I haven't done it since I switched over to a PAT. Okay, let's try launching this. Launch msdev. Nope, still fails. But I really think that this should do an exception. So let's check something stupid. Something really stupid. Source main. Yeah. Classic. This should cause a data abort, which should cause the exception handler to execute. And so we'll just use this until we know the exception handler is working. Because I really do think that I'm getting an exception and it's just not being caught. Tools, USB tools, SD card. Because if this doesn't print anything, then we know that the exception handler is fucked. Oh, nope, I know why the exception handler is fucked. I don't know why I didn't... fuck. I know exactly what's wrong. Program, source, exception handler. See this? Yeah. Do I need to code the BSS for the new BSS for my debug code? No, because it was all null. It is all reified, which means that it is copied in when the image is uncompressed. And that kata is not copied past the initial one, so it's fine. 16 debug. Yeah. Okay. I understand. And yes, MBL, I absolutely dream about coding problems and like wake up having solved them. That's like actually pretty common. There was one day on Mesosphere where I completely seriously worked on a problem in my sleep. Warning section changed to prog bits. That seems like whatever. Wonder why that's a thing. I'm sure it's fine. Yeah, it's still reifying properly, so it's fine. Okay, then let's eject this and try again. Yes, we were spin looping instead of actually executing the exception handler. So that now makes sense. And I bet that we will now see an exception for the one that we just added. Come on, give me, yep, there we are. Awesome. Awesome, awesome. Because we wrote to address 1. Excellent. Now let us do the thing where we don't write to 0x1. Fatal main. Let's just remove that real nice and easy. Yeah, these spreads seem fine to me. I'm sure they're right. I have confidence that I didn't fuck that up, probably. Do you, as a Twitch streamer, think of yourself as above the average person? No, not especially. I mean, I'm just another guy. There's nothing particularly special about me except for the amount of time that I invest into stuff. Okay, let's go. Nice. Okay, that looks a lot better. So let us move the elf into IDA and get looking. Okay, far, we're writing to the PMC, okay. Okay, I see. We are also using the PMC. Doesn't surprise me. Okay. I don't know why I loaded the elf into IDA. The solution is going to be to go to the vapors, source, fuck, I lost my window. Really? Okay. Atmosphere, libraries, lib vapors, source, DD, DDIO mappings, and we'll add the PMC to the list of regions that we know about. I think it's APB dev. PMC probably. That's what I would call it. Might just be PMC though. Let me check that. Okay, yeah, just PMC. Cool. Yeah. Oh man, what a fucking luxury this is. Actually getting real debug output? This is literally better output than I got when I was writing the kernel. Fuck. It's so funny that, like, after all of these years, I finally have printf from this gear monitor. Fuck, the amount of bugs I've had to solve without this are too high. Cool, that's that. Let's check it again. I bathe. I just take showers. I don't take baths. Okay, what's new? 7,000 D1000. Okay, another bit of MIO. Nice. What is 7,000 D1000? I think that's like AUX or something? 1,000 D1000. System address map. 7,000 D1000. That is I2C. Oh, right. Okay. We also need to support I2C. Yeah, let's just add I2C1 and I2C5 in case we need either of them. Five. Also add I2C1 to be safe. I know, right? Things are truly accelerating. Tools, USB tools, SD card, then build and copy it. Okay, then we need to eject it. Close, launch. Let's go. Huh. Okay. It appears that we have successfully initialized the SD card. Excellent. Great. I would, but I need to generate a new personal access token. Nice. Okay. Let's print some stuff out so that I can just be sure that stuff is sane. Sane. And let's see how to remove these, because this seems to just be working now. And what do I do here? I had fuck, where did the code even live? Oh yeah, STMC test. Get the connection status. AMS log, check SD card connection, value. AMS log, SD card. Speed mode. Actually, I don't need this line. Percent. FTPT over Joy-Con. Now that would be a meme. Bus width. Okay. And let us go ahead and do this. Is y'all work? Yeah, this is over Joy-Con UART, A-dubs. This is all just Joy-Con UART. Okay, what did I do wrong here? Port was not. Fuck, that's annoying. What stage of the init? This is actually a fatal error handler, so this is like separate from all the initialization stuff. Atmosphere boots on Mariko right now. There are just some power management problems. Like, don't run the code if you manage to do the like gateway matcha packs yourself yet, because you might damage your hardware, and I take no liability for anything that happens if you run it before it's ready. But it does like work. I booted into it. It's fine. Let's see. So let's check SD card connection. What do I take here? It's speed mode and a bus width. Bus width. Okay. Yeah. Go here. This is just gonna be like a dumb forwarder. Turn STMC check. SD gen port. Okay. Cool. Checked. Close. Close home launch. Messed up. Nice. Okay. Speed mode is 7 and bus width is 1. Let us check what those values mean, because sadly I don't have that good of a memory. The vapors include STMMC types. Bus width 1, so we are in 4-bit mode, and our speed mode is SD card high speed. Okay, that's fine. High speed in 4-bit mode, totally fine. What order do we actually initialize stuff in? Source, STMMC. Well, if we can like actually look at the SD card device accessor when I initialize. What modes do we try to do? Okay, so we failed to initialize SDR104. I think this is an issue with my SD card, where my SD card supports SDR104, but it reports that it doesn't. Like Hecate is having the same problem. It's a UHS, it's a U3 class card, but it's not reporting that it supports SDR104. So it's ending up here, which is fine. So these two fail, and it retries until it succeeds here. Great. Oh, no, actually, we're just in bootloader context, right? Because we don't support UHS in bootloader context. So it's actually succeeding on the first try. So that's even better. Great. Okay. So that's nice. And then what do we do in the STMMC test? Let's just complete the STMMC test so that we're sure that it's working. So your libraries, Sphere STMMC test, it'll be in main. We read 2 vectors here. Okay, so let's make a little helper for ourselves here. Source, let's do program source. Oh, API to look. I mean, we do not need to be fast at all. We can be super slow. So let's just make a dumb read wrapper for now. Destination, the a size, sector index, and a sector count. Okay. Results read. And I'll have void dist size t size. What are the types here? They're probably size of t. Yeah, no, the plan, MBL, is to save the fatal error to the SD card. And then, like, initialize the display and print out the fatal stuff that I normally print in Fuse here without doing a reboot. I'll just do size t, sector, index, size t, sector, count. Yeah, no, I'm super excited about it. And we can't read anywhere because we only have the, like, whatever size memory. So, is inline u8 get SD card DMA buffer. And this will just be this. And, textbar inline size t, parenthesis, SD card DMA buffer size is, this. Okay. DMA buffer size over STMC sector size. Are you going to reuse this method of fatal dumping on Arista or stick with your rebooting panel there? Arista is still going to reboot the panel. This is Mariko only. I don't have, this is in Mariko only trust zone RAM. There is literally not enough space on Arista to include this. So I can't do this on Arista. It's not an option. Well, sector count is greater than 0. Times STMC sector size. Valid. This does not need to be fast, so we're just going to read into the DMA buffer and copy. You can only read sectors. Well, sector count is greater than 0. Size of t cur sectors is standard minimum of sector counts and SD card DMA buffer sectors. We want to try to do a proper read. Let me copy this. Wait. Sectors, time distance, sector size. Oh no, wait, this is not even right. Silly me. We want to read into the DMA buffer. Port and sector index and cur sectors. Okay. And then copy data from the DMA buffer to yeah, put wait SD card DMA buffer. That should be fine because cur sectors is the minimum of the sector count and the SD card DMA buffer sectors. So that should be totally fine. I should do a static assert here. Util is aligned, SD card DMA buffer size, STMC sector size. Because we will only ever read at most the number of things that will fit in the DMA buffer per iteration, so it should be fine, I think. Okay. That's when we need to advance our iterators. And we want to do just U8. Yeah, exactly. Where sectors times system C sector size. Advance the destination by current size. Sector index gets advanced by current sectors, and sector counts gets subtracted by current sectors. I think that should be it. All right, we also want to actually do the read here. Oh, let's read SD card. Okay. Namespace U8 G test buffer STMC sector size times 2. And let's just read the first two sectors, which is what I did here as a test. Read the first two sectors from the SD card. Alt equals read SD card, G test buffer, plays with G test buffer 0, 2. And then log, read SD card, %voidx, old get value. Let's verify that's actually getting written. Then let us dump G test buffer, size of G test buffer. Cool, okay. Let us see what that does for us. Tools SD card. No, because we want it to be in a line down. Right, because we don't want to overread the buffer. Okay. I have a define for that, which is util : divide up, but I don't think I want to do that here. Okay, that looks promising. I see that 55AA. Yeah, okay, that looks like the first two sectors of my SD card. Awesome. Okay, we are in business. We are reading from the SD card from the trust zone context, which is awesome. Okay, I would push this, but I need to generate a personal access token to do that. You know what? Fuck it. We're going to generate a personal access token right now. It'll be fine. Generate new token. I'm doing this off screen, so I apologize to anyone. I know. Let's hope that I can manage to do this without fucking it up again. Right. Okay. Generate token. Okay, let's try this again. This time with feeling. Yeah, I mean, it's not like it really matters if I fuck this up. Git add ... Git restore staged. This because I don't want to commit changes here because they're a temporary hack. M XO read first two SD card sectors in Mariko fiddle. Let's do a git push. So let's here. Change M, and then I need to black the screen. Copy this, and then paste it. I think that worked, and I don't have it up. Now let's make that visible again. Nice. Nice, nice, nice. Okay, and then let me update out of the VM the path that I keep a copy of in my little development folder. Dev. Okay. Okay, that's saved out of the VM. And then, yeah, let's copy this. And yeah, we're good. Okay. Excellent. So that is that. So the next step for doing this will be to hook up this driver to FATFS so that I can mount the SD card and save shit to it. But I don't know how to set up FATFS, so I will have to ask HexKYZ how to do that. And we're at 3.5 hours, so I might call it for today and work on the... how much space do I have left? You mean inside Mariko Trust and RAM? Tons, I'm sure. Let me add this. Tons and tons and tons. This is in Mariko only Trust and RAM, of which there is 128K. I expect us to basically not run out at all. Okay, so we are using... fuck, I loaded the non-debug binary again. We are using 0x93C8 of our 0x20000. So we have 64K plus... FATFS will be fine, because Hec8 and Fuse primary both embed FATFS, and they are RCM payloads, which means that their size need to be less than or equal to 1/8000. And we have 20,000 here, so we're totally Gucci. Yeah, no, we have 3/4-ish of our remaining space left. FATFS will be totally fine. We will have space left over, basically. We have 128K here, which is an absurd amount of space. And if we need more, I gave myself 32K for stack. I could reduce the stack to 16K and then get another 16K of program. I'm not actually going to use 32K of stack, but yeah. Yeah, also I can enable LTO. There are all sorts of options that I could do to make this better. But yeah, awesome. This is super great. I'm really happy that this is working. Okay, yeah, I think I'm going to call that for actual development work here today. Does anyone have anything they would like to ask me before we call it? I will stream myself working on the FATFS stuff, but that will probably be nighttime streams for me. I'm sorry to people who are European, but, I can't stream during the workday. But I do hope that you guys enjoyed the fact that this was at a nice time for people who aren't American. I guess I have to ask, how do we feel about this kind of streaming work in general, which I haven't done in a while, and it was mostly me, blundering around without a clear idea of what I was doing? Is the Mariko crypto system documented anywhere? Probably. I mean, is there anything about the Mariko crypto system you feel like you don't understand? Exosphere implements it, and it's mostly the same. The only real difference is that the boot ROM loads in 2 new keys, the BEC and the KEK, into the security engine. And if I go to Exosphere, program source, program boot setup. So, Balika, FECs aren't loaded into the engine. The boot ROM reads the encrypted Beck and encrypted Keck out of fuses, loads the FEX into the engine, locks out access to the FEC. Yeah, no, the FEX are out of the engine by the time the boot ROM is done. The ROM loads the FEX into the engine, decrypts the Beck and the Keck from fuses using the FEC, and then clears the FEC. The FECs are super critical, boot ROM only. They are the single most important keys in the system. The boot ROM has heavy anti-glitching around them. It is careful as fuck. The only way you're going to get FEC is if you glitch into the UR path. But anyway. Yeah, here is the Mariko stuff. And the keys other than the Keck and the SBK are cleared. The master Keck is derived as being the Keck decrypting the master Keck source. It's literally just the master Keck encrypted by the Mariko Keck. And then the device master key source Keck is just the SBK decrypting static source. And then from this point, the device master key source Keck and the master Keck are used identically to Arista. This is the only different thing. Oh yeah, and the Keck is cleared once it's done. Yeah. Yeah, okay. I'm super happy that this works. I was expecting this to be much harder to get working. But yeah, no, I will probably stream again this week, working on the FATFS stuff. But okay. I hope that you guys have enjoyed. I'll try write SD card. Yeah, write SD card is the same thing, isn't it? Basically. But I don't want to write anything until I really know what I'm doing. Will there be a custom firmware for the chip to load AMS? I am not working on that, and it is very important that I not work on that. Someone else will do it. It is easy enough to get stuff loading that I am sure someone else will do it. But I must not be involved, and so I will not be. But yeah, okay. I hope you all have enjoyed, and have a good one.